Hello everybody. So today will be the next day of practice for MCA, and the learning target today is I can find, identify square roots, rational and irrational numbers. Practice assignment worksheet day 2. You already practice with some of the problems like this as well, and if you still have questions and or haven't completed the worksheet, please make sure you do so. Otherwise, we can move on, and there will be a few things I'm going to ask you to write down on the formula sheet. So, when we're discussing square roots, rational, irrational numbers, always think about real numbers. All of those are real numbers. Real numbers because in the reality we deal with those numbers. Let's think or put it that way. Real numbers have two sections. One it's called rational and the other one it's called irrational. Irrational are the rare numbers and in the other words kind of strange numbers we deal with. For example, if I have square root of 2, this will give me approximately 1.4142113. So all the numbers after the decimal point are just any random mixed numbers that you can think about it. There is no pattern, they do not repeat, it's just variety of numbers. If we have given negative square root of 14, well, that will be a negative number, and same thing, 3.74165781234. It's just keep going in the same random order. Or another irrational is very popular one, pi number. And why pi is irrational? Because the numbers after the decimal point go forever, and they never repeat, or there's no, well, they do repeat, but there is no pattern through. It's just randomly going through the whole thing. So the most common numbers are the one that we use in basic life situations are what we call rational. For example, if I have 3/4, that will be 0.75. Or if you have 3/4 of a dollar, will be 75 cents. You know, that's it. There are no more other numbers around it. If you have negative 1/3, this will be negative 0.33333. It's gonna just repeat. So when we repeat one number like this is also called rational. There are additional two sections to irrational numbers. It calls integers and whole numbers. Now the whole numbers are the numbers that you are becoming familiar with first in your early childhood, and you can count 1 2 3 4 5, and then you are adding 0 to those whole numbers. So whole numbers with whole, this O here, try to remember that there is always 0. And positive numbers. Integers are all others. It has 0, it has positive, negatives, but they are not decimals. So this is the basic description of real numbers, and very, very important one. So I'm gonna write down on the formula sheet probably around real numbers or around perfect square or something, and will point out to myself how do I classify those, because the classification of those numbers is important. So now let's take a look at an example. Imagine you have a question, find all real numbers on the number line. So those are the real numbers given for us. Number 2, square root of 8, negative square root of 9, square root of 16, square root of 64, square root of 32, negative 4, and negative square root of 25. Some of those are perfect squares. So for example, negative square root of 9, well, square root of 9 is 3. So this will be the right place for negative square root of 9 because negative 3 is right here on the number line. Then we have square root of 16. Square root of 16 is 4. So that will be the right place for square root of 16. Then we have square root of 64. Square root of 64 is another perfect square number. And square root of 64 is 8. So that will be the right place for square root of 64. Now let's think about there is one more perfect, negative square root of 25. So square root of 25 is 5. Negative sign up front will show us that the number we're looking for is negative 5. If I have positive 2, well, there it is. If I have negative 4, there it is. We know those. What about if we have square root of 8? Now think about 8 between which two perfect square is. So just take a second and think. And we will say it's between perfect square of 4 and perfect square of 9, because there is no perfect square of 5, 6, or 7. So square root of 4 and square root of 9 will be the perfect. Square root of 4 is 2, square root of 9 is 3, but this is closer to square root of 9, so that will be the right place for square root of 8. And another example similar to this is square root of 32. So what will be the two perfect squares between this? Let's write them down. So square root of 36 will be one of them, and maybe square root of 25 will be the other one, right? This number will be between those two. Okay, between those, right here in the middle. So square root of 25 is 5, square root of 36 is 6, 32 is closer to 36, so we're gonna label that spot and we'll count as a square root of 32. So that's how we order or put on the right spots all those real numbers. Another example could be compare the following numbers. So is 5 greater, equal, or less to square root of 20? Well, if this is not a perfect square, let's think about what will be the two numbers, perfect squares between, and kind of to decide which one of those two will be greater. So I would say square root of 16 and square root of 25. Now, 20 is closer to square root of 16. So kind of this will be in the middle. If this is 4 and this is 5, this number is between 4 and 5. So definitely 5 is greater than square root of 20. Square root of 64 is negative 8. And we have another negative 8 here. So the answer for this will be those two are equal to each other. Square root of 128. Well, square root of 144 is 12. Square root of 122 is 11. So this number is between 11 and 12. And we gotta compare with 11. So if it's between 11 and 12, then square root of 128 is larger than 11. The last one, 6, negative square root of 33. So this will be square root of 25 and square root of negative 25 up front, and square root of 36, which is also negative. So this is negative 5, this one is negative 6, negative square root of 33 is between negative 5 and negative 6. So if it's between negative 5 and negative 6, because it's a negative number, look at this, negative 5 and negative 6 on the number line. If the number is between right here, and we have positive 6, which is all the way right here, definitely this will be the larger number. Or also, for this one, you don't really have to solve it. Think about it. We have a positive and negative number. Just ignore the square root. Which one between the positive and negative is larger? Well, 6 is the right answer. Alright, one more for this lesson and we'll be done. The last question here is order the numbers from least to greatest. Okay, well, let's do that. So negative square root of 16 will be negative 4. Then we have 3.2. Negative 3 divided by 2. So again, this is division symbol, right? The division line. So if you divide or simplify those, you will get negative 1.5. And square root of 9 is 3. So let's go ahead and put those from least. So least to greatest. Well, least is negative 4. Then we have negative 1.5. Then we have 3, and then we have 3.2. Or if you want to use their perfect squares, because think about on the MCA test, they may ask you, to order those with the perfect squares, and this will be just your work. Then negative, we start with negative square root of 16, then negative 3 over 2, then square root of 9, and then 3.2. So that will be the right answer. Alright, more questions during classroom session. Thank you for watching the video.